All right, we'll keep looking at power series in this lesson, and we're going to create power series of functions. In the previous lesson, we were given a series. We weren't given the function, and so we just analyzed the series for its interval of convergence. And so in this one, we're going to start with a function and create a series for it. And we're going to have specific functions that can use this formula for the sum of a geometric series. So let's start by thinking of this equation and that equation where r is a common ratio and then x is any real number. Pause the video and compare and contrast those equations. And what we see is we know that this formula does have an A1. The first term of the sequence is part of the formula, and here I didn't have anything written there, so we would say that it's a 1. So the first term is a 1, and if the common ratio is r, then we would just go 1 times r, and then r times r times r, and then, so this would be the series, and that would be the sum of this series. If we just compare that or replace the r with an x, now we have a function, a series whose sum is going to be this function is represented by this series, but not for all real numbers, because look at, if x is a large number, like x is 10, you know, that goes to infinity, it's not going to converge to the value of this on the graph. So we need to remember that this only works, this is only true for the common ratio less than 1. So that means this series is the same as this function only when the absolute value of x is less than 1. So we know this graph, let's see, it's going to be, if we just switch the order there, and we have an asymptote, vertical asymptote at 1, and instead of being on the top, it's going to be on the bottom. Let's check the y-intercept is going to be, the y-intercept is 1, so the graph will go like this. And this series will be the same as this graph. The values of this will be the same as this graph between 1 and negative 1. So if this is 1, between 1 and negative 1, the graph of this will be exactly the same as the graph of the given function. And so our goal today is to rewrite functions to look like this, and then we'll know what the series is going to be. Let's start by rewriting these functions to look like this. It can be a number over 1 minus something with a variable in it. So we have to rewrite this one. We want it to be, our goal is 1 minus x, so we could write it like this, and then we could put the negative in the numerator, and now it's in the desired form, a number over 1 minus some variable. Here we have the right order. We have the number first, minus x, which we want, but it's not a 1, so we can do that, and now we'll put it as 1/2 in the numerator, and it's in the right form, a number over 1 minus r. Here we don't even have a we don't have a binomial in the denominator, so we can be creative and just put one there. Well, that's not right. We can't just subtract 1, so we'll add 1 also, and then just rearrange it as to what we need to have. We want to have the positive 1 it has to be a positive and a negative. So for now, I'm going to look at it like this. So I had x minus 1, and I just moved that 1 in front because I know I want there to be a 1 there. And then we can just factor out a negative. So it's in the right form, something with a variable, 1 minus something with a variable. All right, pause the video and do the same with that. Remember, the goal is to make it look like that. So we don't have a binomial, so that's where we can subtract 1 and add 1. Let's think of this as being together, and we'll go 1 plus 2x minus 1, and then just factor out a negative, 1 minus 2x. Here we have 3 in the correct place as the 1, but we don't want it to be a 3, we want it to be a 1. That means we can just factor out a 3. And now we have it in the correct form. This one, we want the 1 to be first. So we could say negative 1 plus 2x. Well, we're getting to the right form. We have the 1 first, but it needs to be a positive, and then we have to have subtraction. So we can just factor out a negative, and then put the negative in the numerator. And now we have a number over 1 minus something with a variable. All right. So we have this, and we want to make it look like this, and then from that we can do this AR to the n equals 0 to infinity. So we need to make this look like that, and let's start by doing that. We want the variable second. We don't want there to be a 2 there, so 2, and factor out a 2. And put the 2 in the numerator, so it's 3 halves. And we don't want addition, we need to have subtraction. So we'll write it as 1 minus negative x over 2, and we're done. Then we see that the a is 3 over 2, and the r is negative x over 2. A, and that'll give us the function is the series with a r to the n. It is equal if negative x minus 2 is less than 1, so we could have the interval of convergence is negative 2 to 2. All right. Pause the video and try that one. We want it to look like this, and that means let's start by changing the order. Then we just have to write it like that. So a is 4, r is negative 3x. F of x equals the series with a is 4, r is negative 3x to the n, and we want this is equal to that only when that is less than 1. And we get negative 1/3 is less than x is less than 1/3. Okay, those were centered at 0. Now we have to look at how do we get it centered at some other value. All right, and so we start with this, the same function, but now we want to center it somewhere else. And that means that our goal is going to be a over, and it has to be, it's still 1 minus r, but this r has to be an x minus 2. So by having x minus 2, that means it's centered at 2, and we're going to just put it where we want it to be. We want there to be an x minus 2, so we're going to just write it like that. Now, this is not equal to that. This is not equal to that. It has what we want. All we have to do is do the opposite of what this did. So this, by writing the minus 2, it created a negative 6, so I just have to add 6. And now this is equal to that. Then we can start simplifying. We want it to, we have a 7. Let's write 7 plus 3, x minus 2. We don't want the 7. We want it to be a 1. So we'll factor out a 7. 3 over 7, x minus 2. and that changes into 4 over 7, 1 minus negative 3 over 7, x minus 2. And that gives us the series A sigma A R to the n, and that will converge when this is between 1 and negative 1. And we're going to add 6/3 to both sides. So remember, we need to have appearing in place of r, there has to be an x minus negative 1. Pause the video and try this one. We want it to be a over 1 minus r, but we need to see x minus negative 1 be somewhere in that expression for r. And that means we're looking for x plus 1 to appear in there. We could break this up, just use one of these, break the 2 up, but why don't we just always do it the same way, and we'll just write in what we want it to be. We want this x to be an x plus 1, so I just replaced it with what I want, and then I have to do the opposite of what this does. That means we'll subtract 1. So we have 3. 2 minus 1 is 1. X plus 1. And then we'll just write it as 1 minus negative x plus 1. And now we have a here, f of x is equal to a r to the n, and that's true if r is less than 1. So we have x plus 1 is less than 1, negative 1. So it'll converge between negative 2 and 0. All right. pause the video and try that one. And we want the function to look like that, but r needs to have a x minus 1 in it. So let's just put it in there, x minus 1. Replace that with x minus 1 because that's what we want, and then add the thing that we have to do this to cancel what we did, so that this is the same as what we started with. And then we just manipulate that to look like what we need, 1 minus the expression, and it gives us the series as n goes to infinity. Just the a is 1, and then negative x minus 1 to the n. So that is equal to f if and then we get x minus 1 is less than 1, between negative 1 and 1, and we'll add 2, add 1, and then add 1 there, and it'll converge between 0 and 2, and it is centered at 1. All right, and we'll stop there.